My name is Lindsay. I'm here from the coalition. Just before we get started, I'll introduce Kent. He wants to give a couple opening words for our webinar, and then we'll jump into the presentation about using Rescreen in the healthcare environment. We have Stephen, Kevin, Dinesh here also from Rescreen. So we'll get started. Kent?
Thank you, Lindsay. Welcome, everybody. It's Kent Wadding from the Coalition. I just wanted to take a minute and thank everybody for joining us in this call. Also to thank Natural Resources Canada, the Rescreen people, Dinesh and Kevin, for entrusting us with some work this year. And this webinar that you're joining is part of that work. So again, thanks everybody for joining. Thank you, Dinesh and Kevin, for funding us this year. And Lindsay, it's all yours.
Awesome. So to start off with, like I said, we have three speakers here today. We have DJ, Kevin, and Stephen as well. So I'll pass the floor over to our presenters. And again, just a quick reminder, if you have questions throughout the duration of the webinar, please feel free to put them in the chat function. And the webinar is being recorded and will be sent out after we're all wrapped up. So thanks so much, and let's get started.
Okay, hello and welcome everybody. It's JJ Knott from Healthcare Energy Leaders Canada. I want to welcome everyone to this webinar on Rescreen Expert Clean Energy Management Software. Slide, please, Lynn.
Yep. There we go.
Yeah, just a little bit about today's agenda. We'll spend some time discussing the new Rescreen product and what it can do for you. And then we'll get into, later on in the program, some actual applications in Rescreen. And finally, if we have time, if someone has some questions related to projects they are working on, we can discuss how Rescreen could be used to come up with solutions for them, as I say, as time allows. Next slide. So today's presenters are myself, of course, not project lead for Healthcare Energy Leaders Canada. We also have with us Stephen Dixon, and Stephen is probably one of Canada's most experienced and recognized energy trainers and has extensive experience in development and training around Rescreen. Stephen comes to us by way of his company, No Energy, and I'm sure a lot of you know Stephen. We also have with us Kevin Bork, and he's part of the development team of the Rescreen Clean Energy Management Software at Natural Resources Canada, CanMet Energy Research Center in Varennes, Quebec. He specializes in Rescreen software development, providing Rescreen software technical support, and developing online distance learning tools such as the e-textbook and case studies. Prior to joining and Kevin worked as a wind energy consultant specializing in the assessment, modeling, and performance analysis of wind energy systems. He's been working in the energy field since 1999, Bachelor of Engineering from McGill University. And of course, there are likely a few Rescreen users on this webinar, and we look forward to your comments and questions later in the program. Next slide, please. So just a few words about the Canadian Coalition for Green Healthcare. Next slide, Lindsay.
There we go.
Okay. As you can see, the Coalition for Green Healthcare, we're involved in a number of fields related to energy and environmental matters that impact healthcare across Canada. And we're a good source of information, and always a good idea if you haven't joined the coalition, not that much of a fee to do so, but it is a good source of information on a lot of fronts. From here, I'll turn the next two slides over to Kevin.
Thank you, JJ. And if everyone can hear me. Yep. Okay, great. So on the screen right now is what you first get your first see when you download and install and open the Rescreen software. And for those of you who maybe aren't familiar with the software, we'll get to see it a little bit more, a little bit in action a little bit later. But whenever I open the software, I always pause a moment and just sort of orient myself. And right in the middle of the screen here is what we call the project workflow. And it kind of defines the major areas of types of analysis that you can do with Rescreen. There's benchmark analysis, a feasibility analysis or energy audit, and then performance analysis and performance tracking and sustainability. And in that inner circle with the arrows show all the various sub-sheets and sub-parts of the software that you get to access. And so today we'll be focusing on a couple of these. Once you orient yourself using either the column to the left of that or the right to that can really get you started into the specific part of the software. And then on the right-hand side, we have the various resources that are available in the software, and I'll get to talk about that in a couple of minutes. But keeping in mind the three main areas, and if you look at the left-hand column and also echoed on the outer circle of this project workflow, we're really talking about benchmark analysis, feasibility analysis, and performance analysis in Rescreen. And that's for a specific facility or specific project. And if you do multiple projects or multiple facilities, you can aggregate those into a portfolio, and that's another important aspect. Next slide, please. So this matrix here describes what we call the Rescreen Enterprise Initiative, and that's where we work hand in hand with owners of multiple facilities to integrate Rescreen into their portfolio-wide sustainability and energy management. And as you move from left to right in this matrix, what you're doing is you're adding more and more information. And as you go from top to bottom, you're adding more and more facilities. So if we start, and it's all anchored at the upper left-hand corner through something called Rescreen Connect. And that's our API, our application programming interface, that lets us automate a lot of the heavy lifting in the data department. And if I look at the middle row here, if we start on the left-hand side, the virtual energy analyzer, what you're doing is you're really just describing your facility. And then moving to the right, we have a benchmark analysis where you start deciding, what you want to compare your building to. And then moving forward, consumption and production monitoring, just collecting the billing data. And then moving to the right again, measurement and verification, normalizing some of that data and going down even to the daily level. And then all the way to the right-hand side, looking at feasibility analysis, either for a whole building part of it or down just to an individual measure. And then if you can do each of those steps on multiple buildings and aggregate those into a portfolio-wide analysis, and that's the bottom row. And we'll go over each of these a little bit later. Next step, and I believe JJ will talk a little bit.
Okay, so that brings us to the question, so why use a Rescreen? Well, the next few slides may contain the answers you were looking for. First of all, simplification. We're all looking for ways to make our job easier. It simplifies the energy conservation measure feasibility assessment and gives you a quick means to compare project options. And just by way of an example of this, if you were approached and you had proposals to do roof replacement and insulation upgrade 4 different ways, if you had 4 different options presented to you, you could quickly analyze each of those options through Rescreen and come up with what's the best project for you in terms of payback, in terms of return on investment and net present value. You can apply many things to any given project and come up with the answers that you need. Next slide, Lindsay. Standardization. Rescreen uses validated technologies to help get to those apples-to-apples comparisons of potential project options. And because they're validated technologies, the results that you get are good in terms of applying for incentive towards projects. because, those that are doling out the funds are looking for, validated answers as to, what could this project. And also, by going through RETScreen, the results can increase the potential for project success. As you're comparing those apples to apples, you're much more likely to come up with a successful project through the equations and the calculations that you get through RETScreen. It creates useful information that can also be applied to budget prioritization process. I'm sure everybody's familiar with that this time of year. Next slide, Persuasion. One of the most difficult tasks as facility managers is convincing the C-suites that a project has great potential, and we all know what that is like. Through the graphing tools like regression charts, QSIM, pie charts, we have a host of great reporting platforms at our fingertips through RETScreen. And reports are automatically generated, and you gotta love that. As a facility manager, I'm sure you're inundated with requests for reports on different things. And RETScreen does that all for you automatically. It includes even the cover page, executive summary, and all the supporting that you need. You just pick from the menu and out it comes. And as for those VPs of finance, RETScreen has all the finance reporting capability you need. Anything from calculation of net present value, return on investment, interest and discounting calculations, you name it, it's there. Next slide. Finally, we have interoperability. RETScreen is a great fit and a tool that can be used to support things like the Green Hospital Scorecard reporting. It works alongside Portfolio Manager for those that are already using that tool. Energy Star, so you can take Energy Star rated equipment and pull some of those calculations into RETScreen and actually make comparisons through RETScreen with different pieces of equipment, because it has a complete library of equipment within it. And it certainly goes a long way to supporting those legislated reporting requirements. Things like conservation demand management plans, emissions reporting, a lot of other legislated reporting requirements through RETScreen. Back over to Kevin.
Thanks, JJ. So if you remember that matrix that I showed before, or also on the if you have RETScreen open, the first thing you see on that left-hand menu, let's go down now and talk about some of the things that are in RETScreen. The first thing is a virtual energy analyzer, which is your gateway into complete projects by the use of archetypes. So archetypes are typical buildings, including full costing, and they can be customized and reconciled with data that you have. And it automatically loads the project information, climate information, and really locates it exactly in the world so that you have access to near real-time satellite data as well for weather information and so on. Next slide, please. Once you have your project loaded, the first thing you'll see is you get the opportunity to benchmark. So that's being able to compare your project with benchmarks, whether those be corporate benchmarks, buildings that are of a similar use, and then have your base case and a target in terms of energy use intensity. And beyond just energy and fuel, you now in RETScreen can have benchmarks for emissions and costs as well. And these are all dynamic and change with the facility size that you put in. Next slide, please. The next thing is you can go into the feasibility analysis, and this is really where you start modeling and doing the energy calculations on a base case and a proposed case, so the technology that you're going to be proposing. It includes also the cost of the initial cost and the ongoing operation and maintenance of those systems, those proposed systems, as well as the fuel savings and the costs associated with that. There's also a very detailed financial analysis using a lot of different financial viability indicators, as well as automatic emissions calculation. And you really can go quite deep into the emissions calculation, specifying unique emissions factors if you need to do that. And then, of course, this is really just a snapshot, so it's important to get a sense of the sensitivity and risk, and you do that through the sensitivity and risk analysis in RetScreen by varying the various inputs of the model to see where you should be focusing your efforts. Next slide, please. One big thing in RetScreen is that you're able to do what we call performance analysis. So this can start off with just tracking your bill, doing energy tracking, monitoring, tracking, and reporting, and even going even further to looking at daily data and normalizing that through the use of various baselining techniques, such as regression and doing a Q-sum. And also even going with the NNV, measurement and verification, where you can identify the impact of certain events, reset your baseline, and really normalize it according to heating degree days or cooling degree days, or in a healthcare center, the number of hospital beds or the patient throughput, or weekends, weekdays, and so on and so forth. There's lots of other reporting and dashboard options as well that really gets you really to understand the energy and the energy of your building. Next slide, please. So far we've been talking about one building, but hospitals in particular generally have multiple facilities. Or if you're working in a health region, there's healthcare facilities across a geographic area. So you can do everything I've mentioned before, from the feasibility analysis, performance analysis, benchmark analysis, and so on, and aggregate those into a portfolio analysis where you're looking at these factors and rolling them up for multiple facilities. It will take into account the various climate and weather differences if you're looking at a wide geographic distribution. And it also allows you to see what the effect is of doing multiple, replicating and measures on multiple buildings. Next slide, please. And so, RetScreen does require a lot of data, and to ease you into that, there's a ton of RetScreen databases in the software itself. We have product databases with many, many thousands of different products in there, including manufacturers and the specific performance specs that you will need in the analysis. In addition, a really important thing is an initial cost estimate. So we have updated cost databases that includes both the initial costs and the O&M costs. And furthermore, you can customize these databases and escalate them so that it represents the cost in your region as well. We also have a climate database, which includes tens of thousands of climate stations all around the world, as well as a link to NASA's near real-time satellite weather database. So we have climate, which is long-term averages, but also weather database right at your fingertips at a fairly high resolution, as well as hydrological data. We have solar radiation maps, wind maps, and so on if you're looking at the renewables side. Next slide, please. So, of course, under the healthcare banner, that falls within RetScreen in what we call the commercial institutional space, but you can also look at just all sorts of different types, whether it's residential or hospices and food courts and residences and university buildings that might be a part of a healthcare facility, research labs, and so on. You can also focus on just individual measures. So you can just look at, say, various speed drives, or the motors for the elevator system, or the lighting, or the ventilation systems, or cooling systems for the various gases and different things that are needed at the hospital. Also in Rescreen, we now have, and is available right now on our website, our cogen, trigen system, and that includes power, heating, and cooling, and any combination thereof. And that also includes the district heating and district cooling, the district energy model as well. So that's also very pertinent to the healthcare sector. And then, of course, if you get into the renewables, as I mentioned before, you can look at solar power and solar heat, photovoltaics, as well as gas and steam turbines, microturbines, fuel cells, and so on. So Rescreen really does have everything you need to do those preliminary analysis and to really get your project started. And with that, let's jump into the software itself. And next slide, and I believe Stephen.
Great. So what I'm going to do for the next 4 or 5 slides is just go through the examples that I'm going to actually show you in Rescreen. Well, I don't want to be jumping back and forth between the software and the PowerPoint. It makes it a little bit jumpy. So we're going to do an individual measure. So, okay, hang on a second. Linksy, I don't need that quite yet. Okay. Yeah. So what we're going to be doing is going through a number of different measures and different projects within it. So on the next slide, the first project that we're going to look at, it will be a standalone measure. This example actually came out of a workshop years ago I was doing, and maybe one of the people on the line today asked me that question in the workshop. But they had a long-term care home, and they were sitting in the workshop, and their contractor just called them and said, "Hey, we're going to be putting the nominal 2 inches of insulation back on this roof when we re-roof section of the building, but you know, for an additional 48 cents a square foot, we're prepared to give you 4 inches of insulation." The question then becomes, is it worthwhile doing it? And that question was literally posed to me in a workshop. So I'll take you through that example and actually take it all the way out to looking at the net present value and the internal rate of return on that as well, so the financial side. That's the first example. The second example, next slide, is going to be a window upgrade. So we'll start off with a building, which is actually one of the archetypes in Rescreen for a healthcare clinic facility. And I'll go in there and I'll actually, I've modified the archetype already to represent the envelope of the building as we have it now. I'll go in and I'll upgrade the windows, calculating the savings for that window upgrade, and we'll look at also the impact on infiltration. And ultimately then, we'll be able to look at the financial impact of that as well. So again, the first example was just sort of a on-the-fly type of calculation. Now this actually becomes a more of a robust project calculation. So next slide. We're going to work on a lighting example. So within our archetypal building, we're going to add a space, and we're going to calculate savings for moving from, I believe, T8s to LED lighting today. And I'll show you how to use a product sheet from a manufacturer and literally take the most current information we have. Even though the database in Rescreen has numbers in it, we'll actually make sure we're using the most up-to-date efficacy or efficiency information on a particular type of light source. So next situation will be demand-controlled ventilation. So we'll be looking at a system that moves 100% air inside and out, and we'll look at set point changes, and we'll look at scheduling changes, that is moving from 24/7 to some lesser period of time, and we'll show the impact a VFD can have. We'll estimate the savings for both the heat reduction and cooling reduction for the VFD, but also for the electricity as well. And the final example that we'll work on will be this performance analysis example. This is a heat recovery situation on a hospital boiler. This is a real situation. Years ago, it was presented to me, and we went through it, and it's kind of interesting. And we actually can see both the savings, but an operational mistake, if I can call it that way. And by monitoring with Rescreen, you can catch those things sooner than later and make sure you don't lose savings over the long run. So at this point, we will change over to the software, and I'll begin with the first roofing project. And I'm going to use, depending on the time we have available here, I'm going to use sort of pre-cooked or almost finished examples and just finish them off. So I guess I'm going to request control here. And so.
You're good to go, Stephen.
I'm good to go? Okay.
Yeah.
So there we go. So everybody should see a nice sunset there, Prince Edward Island, for those that know me, a place I like to go. but today we're going to go to Rescreen. So here's the Rescreen interface. And we're going to start, we're going to create a whole situation here. We're going to have to calculate the savings for changing this installation, our 10 to our 20, but I'm going to create the roof, I'm going to create the heating and the cooling system that goes to go along with it. So literally right from scratch. So I'm going to jump right in, and I'm going to specify the type of facility and where it's at. So location is in Brent, Quebec. I'm cool with that, right? So we're going to pretend that this hospital is near Montreal. And the type of facility then isn't a photovoltaic power plant. It will be an institutional facility, and I can specify healthcare. The neat thing about Rescreen is these pictures that you see in here are customizable. So if you don't like the picture that's there, you can basically add your own image. On this screen, we also see some of the benchmarking information that Kevin talked about. We won't cover that today, but suffice it to say it's there. I can also add notes and things like that. So if I wanted to actually do some word processing on this page, I have a neat little word processor here as well that I can make notes about this particular project. Now I jump to my energy tab simulator, and at this point, I've got some tasks to do. I have to create schedules for this project. I have to tell it what energies I'm going to be using, electricity, natural gas, what the price of energy is. Then I have to put the heating and cooling equipment in. I'm going to have to add a boiler. I'm going to have to add an air conditioning system, and then I'll add the roof in order to do the actual calculation. But at the end of the day, once you set one of these up, it actually moves along pretty swiftly. So the default values that I have programmed for my natural gas are 30 cents a cubic meter and say 10 cents a kilowatt hour. I might want to move that up to say 12 cents. And this is the marginal price for electricity. This does not include demand. So when you're doing these calculations, if you want to include a demand calculation, you would add that in as an additional O&M savings later on. So this is the marginal energy price used to evaluate the savings, which will become the difference of what we'll see as the proposed and the base case situations. I'm going to add a schedule. I need to tell Rescreen what temperature I'm maintaining building. So in long-term care home, I would probably be, I'm sure I can be corrected on this, but I'll probably be heating to 22 and maybe cooling to 24. I'm going to use a 24/7 schedule just for simplicity. In another example, I'll actually use a slightly different schedule. And I need to specify the length of the heating cooling system. In Rescreen, we use heating, in this aspect of Rescreen, we use heating and cooling degree days to determine the conditions outside the building from 20-year average climate data. Actually, I should mention that when you specify your location, you actually automatically access within this feasibility aspect of Rescreen climate data, 20-year average data, heating and cooling degree days, which describe how cold and how warm it is outside. But also, depending on the process that we're doing, there are other climate parameters here as well. And again, those are also available in the performance analysis later on, where we'll be dealing with weather data, what it was yesterday, the day before, and so on. So when I say weather, I mean short term. When I say climate, I mean long term. So we're going to do this calculation on long term climate averages. So I'm going to specify that this building has a changeover temperature from heating to cooling at approximately 16 degrees C. Depending on the building that I'm in, I may move that down and move that up. If your building basically changes over a lower temperature or a higher temperature, you can make some minor adjustments here. It's akin, for those that are aware of balance point temperatures and degree days, it's akin to that, but not exactly the same. Okay, so we specify the electricity and the schedules. Now I need to add a piece of heating equipment. So I'm going to specify a boiler, and I can add a lot of information about this boiler. I can specify information in terms of the model, manufacturer, the capacity, and so on. But from the point of view of doing the calculations, all I really need to know is how efficient at converting gas to heat. So I'm going to use a number like 75%, assuming this is probably in a hospital or steam boiler. And I'm going to do that in both the base and the proposed case condition. That allows me to have a boiler. I'm going to calculate my base case, which is the way the building is now. I'm going to calculate the proposed case the way I want it to be, and then it will calculate the energy use in both, take the difference, and that becomes my savings. Okay, now I need a piece of cooling equipment. So I'm going to specify a compressor-based cooling system. Let's say this area of the building has a rooftop unit or maybe a larger chiller. I need to specify, again, the efficiency of the chiller, and we can do that in one of two ways, either the seasonal energy efficiency ratio or the COP, the coefficient performance. If you're ever wondering what value to put in a Rescreen, one of the really, really cool features is to click on or hover over top of the label that it's asking you for here, coefficient performance seasonal, click down, and you'll get a window that comes out actually tells you what it's after. And in many cases, you'll get a table of typical values that you can use here. This is really, really useful because often you're stuck. Well, what is this? You know, what could be the efficiency of this? Let's get started. Let's pick a number from this table and not get stuck on the details. If things look promising, we may want to go back, talk to the manufacturer, go look in the specs of the unit, and actually refine this number. But this gets you to first base really, really quick. I'm going to go here right now for my base case, and I'm going to use another really cool feature of Rescreen, copy base to propose, which is my base and my proposed case are identical. That means I don't get savings when I don't want them, savings due to my errors in input. Okay, we're almost there now. We've got our heating, our cooling system in, we know our fuels and schedules, so now we have to go and actually specify the roof. And to do that, I move to energy, and I pull out all the different units that can model the Rescreen. And the first one on the list is the building envelope. That's the one I'm going to use because that's the one that contains the roof. Here we go. We have a building envelope element created. You might notice over on the left-hand side, as I create each one of these elements, it actually adds a specification into the list here of the fuels or schedules, equipment, or end use. Later on, when I open up an archetypal building, you're going to see all of this filled in, the whole building in its entirety specified here, and we can move around and modify and so on. Now, I need a roof, so I'm going to click on the roof box here, and it brings up the roof. I know the square footage of the roof is 10,000. Rescreen is really adept at dealing with different units, so I don't like metric units. I don't have information in metric units. I'll specify the units that I want. So 10,000 square feet is the area. And again, I don't know what the R value is in metric, so I'm going to go, and 2 is a rigid inflation, which is the deep that we would replace with. I'm going to go with R10. Now, I do need to tell Rescreen which way this building faces. Rescreen often does calculation, especially with windows, with respect to the sun and solar gains and so on. So there's a very important number here, which is the north side of the building, to me, which way does it face with respect to the compass? And again, I'm going to use the help to take up this and realize that building north, right, what I call building north, it might be, say, 10 degrees east of north. So that's what this example shows here. So I'm going to go ahead and I'm going to use 10 degrees east of north just to, as an example. So what I'm saying here is my north face faces 10 east of north. Okay, so we're almost done. We have some numbers at the bottom here, but we only have numbers for heating. So this is the base case heating assumption. If I specify that the system selection is heating and cooling, now at the bottom I get my heating and my cooling requirement for this particular element of the building, that being the roof with an R value of 10. At this point, I want to make sure my base and my proposed are identical, so I go ahead and use copy base proposed. I check down the bottom. I don't have any savings. That's good. It didn't make any errors. Now I can simply add any information, which is ultimately what the root of the question was. If we go to R20, right, at 48 cents a square foot, which would be $4,800, is it worth doing this, right? So we click that in. We see we have some savings here. That's cool. Well, we know it's going to save 50% of the energy through the roof. That's kind of a no-brainer. But what does that really mean in this locale with size and so on? So in order question, we go to what we call the include measures screen, which is where we get to see the results. And lo and behold, we see that the payback for the marginal increase in insulation level here is 4.9 years. So I think most people, realizing that this roof has a life of 15 to 20 years, would probably go for this. And that was the answer that the gentleman kind of wanted in the workshop, and in fact, he got based on his locale and his price of energy and so on. So you could take this building now and move it anywhere and do the same calculation with just basically one click. Now, for those that are into the financial side of this, let's take this a little further. If I could develop this as a project, I have a pretty powerful project management or project development tool where I can specify more detail. So I can do a really detailed cost analysis. This is a great checklist. If projects, you know, it's always the little things that add up that catch you, and this is a great checklist to make sure those things don't cause you grief in the long run. Under periodic costs, even if we have to maintain this roof, we can put in periodic costs for maintaining the roof over that 20-year life. Interestingly enough, today, emissions are very important to people. So Rescreen immediately shows us what the greenhouse gas emission reductions are, both from natural gas and for electricity. We just have to make sure we use the right factor. So I would say the factor here in Ontario right now is about 0.04. Let me get this right here. All right, there we go, tons per megawatt hour. And when I click that in, and so now I'm basically showing the savings in our locale. Okay. Actually, should that be? Anyway, I'm going to move on to finance. Under finance, I can actually a fairly nice little financial analysis here. We have what we call our level 1 financial analysis with some default financial parameters. I like the level 2 because it tells me a lot more. Right? So I'm going to go to financial analysis. I'm going to specify that we have an escalation rate on energies of 2%. General inflation, if I had periodic costs for maintenance and so on in here, that would be escalated at a rate of 2%. The discount rate, what's the cost of the money that we're putting into this project? What's the weighted cost of capital? What's the opportunity cost? So for an institution like a hospital, I suspect it's probably today around 3%. Now, I'm going to calculate the internal rate of return, but in fact, a more reasonable estimate of that, which is the modified internal rate of return, which determines from the financial folks' point of view, we're not going to take the money that this project generates in savings and reinvest it at the face value of the project. We're probably going to invest it closer to our discount rate. So I'm going to use a reinvestment rate of 3%. I'm going to tell it we've got a project life of 20 years, and that's got to be tied to how long this project will be delivering savings. I'm not going to borrow any money for this project right now. I've done that. Now I can cruise down to the bottom here, and I can see my cash flow graph, right, which is pretty neat. But the thing I really like is to look at something like the modified internal rate of return, right, on assets. So this project is like basically a bank account that's returning 10%. The other thing I really like is this thing called the benefit to cost ratio, sometimes known as the savings to investment ratio. Many people gravitate to the simple payback of 5 years. That's like saying, how long do I have to wait to get my money back? But the thing I like to ask is, in 20 years, how many more times money do you give me back? That is, if I give you $1, this project gives me $3.7 back over 20 years. To me, that's a much better measure of the financial value of a project like this. At the end of the day, one of the things you'll discover in using this type of calculator is that most energy projects are probably some of the best things you can invest your money in, whether it be at work or at home for that matter. So that's a quick glimpse of doing a very standalone project, going to a financial analysis with the project development tools, the costing, and the tech aspects, or we actually look at what's happening at the roof of the building. Very, very quick little one. We're at 339 here. So that's the first project. The second project was a whole building example where we look at windows. Let's go back and look at that one. So in order to begin this project, I'll just go ahead and save one, and I'll probably be sending these files out afterwards through in conjunction with Kent. So Kent, you can distribute those to everybody. So my next project that I want to work on is I want to open up a whole building example. So what I've done here is I've gone and accessed one of the archetypes that Kevin talked about earlier through the virtual energy analyzer. I can click in here and I can bring up that it's a healthcare building, and I can specify the location of the building. I've done it for London, Ontario, somewhere west of here. So I've already done all. So it's already kind of like the cooking show, all pre-cooked. I'm going to run over here, and I'm going to look at my archetype. Now, wow, look at what we have here now. Before we were looking at 4 or 5 items in this. Now we have like literally a plethora of these things. All, everything from the envelope to ventilation to lights to electrical equipment to hot water to fans and motors, including the elevator. And then down here at the bottom, we actually have sort of embedded renewable energy. This is not a feed-in tariff type of system where you're getting a buyback rate for the energy. This is an embedded solar hot water heater and embedded photovoltaic system, which is displacing the energy used by this building. So we've actually basically the entire building with a few clicks here, and we can do a few projects. One of them will be the window upgrade, and one of them will be the light upgrade. Now, I can, when I do this type of thing, when I do these types of projects myself. What I really like to do is to do a what I call reconciliation or calibration to existing consumption. So let's say that I had 60,000 cubic meters of gas that I was using in the small clinic, right? And I was using 160,000 kilowatt hours of electricity. Then Rescreen will tell me in this little project or this fuel consumption variance and verification section, it'll tell me how close I am to the historical consumption of the building. I use this to build a model and to make sure that it's reasonably calibrated or reconciled to what we used historically. That way I have a good starting point. I know that I'm not making a bunch of rash assumptions. I once saw an energy audit report. Most energy audits in my world should be done this way, but I saw an energy audit report that said, assume that the building is doing this, the savings for ventilation systems will be this, and they predicted savings which were greater than the building actually consumed. Well, if you use the tools here, you'd never get into that situation, but that does happen. All right, so let's go and take a look at the building envelope. Here, built a fit, robust building. It's a little bit west of north. It's got north, south, east, and west-facing walls, windows. We can specify solar shading on the windows. We've got doors. We've got a roof. We've got a floor below grade, right? Basically a slab on grade kind of construction with a perimeter. And then down here, we actually have specification of the natural air infiltration in addition to what might happen through ventilation. So everything is completely specified here, and we're going to focus in on the windows. Right now, we have existing windows that have a U value on all facings of 3.2. And interesting in Rescreen is if you want to convert that to an R value of the window, right, you can simply change the units and it will do the conversion for you. So I can change this over to an R value here. I'll go back. So basically all of those calculations are done for us automatically. So right now we've got an existing U value of 3.2 and a solar heat gain coefficient of 0.6, which is not a good window. Down in the instance section, we can see that this window is specified to be leaky, which is, again, not a good situation. I'm going to make sure my base and my proposed case situations are identical, right, so we don't see any savings in the bottom. And then I'm going to go ahead and modify the windows in this particular building. I'm going to go with a nice high-performance triple glazed window. If we're going to change these windows, we might as well go for the gusto. So 1.3 will be my U value in each of the four facings that we have here. I mean, you don't have to do all four of them in a real situation, but typically you would want to make your building as good as you can, as good as you can afford. And we're going to reduce the solar heat gain coefficient to 0.4, right, which is probably as good as you can expect on a typical new window today, triple glazed window. And again, if you're in doubt about the parameters of these windows, you can simply click on the help over here. We got our help. Up here, we see some typical values for windows. It's a little bit hard to see. I'll blow that up. But here some of the values that we might have. So I'm basically moving towards one of the best windows in this test right now. Again, Rescreen is helping us to do that. Now, Rescreen, what cost of that window? So we could, again, click into the cost table in Rescreen. Just for expedience here, I've already done it. I'm going to go with a number like $70,000 for these windows. All right. So we've improved the windows. But we also have improved tightness because we're going to take that window from a leaky one to a tight window. And at this point, Rescreen is calculating for the energy reduction at the point of end use, meaning at the window. And if cruise over to our include measure screen, we are completely lost because we can't find what's going on all the measures. Well, another really good feature of Rescreen is we say, uninclude all measures, and then we go through it. I just want to do the measures in there we go. So we click on the click as the measure we want to look at, and now we simply see the savings for that particular measure. So here we're looking at about an 8.5, maybe 9-year payback for these windows. Probably doesn't surprise anybody. But again, given the life of a window, and if we buy a good one, then this is probably a project we would want to go ahead with. And if we're upgrading windows, why not calculate this and add this to our project benefits? Regardless of whether we did it for an energy reason or an asset improvement reason, for that matter. So we're getting there. We've done two projects now. We're going to move on to the third project at this point, and we can simply do that within the same context here. I've actually built within this particular. Beg pardon, somebody.
Hi. So just a quick note. Just make sure I am unable to mute whoever was just speaking because they're calling in from a phone. But just please make sure to *6 yourself until the end of the webinar. Thank you so much, and go ahead, Stephen.
No problem. Yeah. So basically, what I've done here is I built an activity area in the building, which is akin to a gymnasium. I specified the type of space, and we have a feature screen whereby we know the type of screen will suggest to us what the illumination level will be. So that's handy. And it will also make sure that we don't get the wrong illumination level afterwards, means reduce it. So right now my base case is in place, and I'm going to make sure my base and my proposed case are the same, and then I'm going to proceed to upgrade the lights in this space. So in this case, I'm going to use the lighting database, right? So I'm going to click into the database feature. It comes up with the database of all the lights. And I'm going to be using, in this case, just to spread the wealth around a little bit, not going with one actor, I'm going to specify an LED light. So I'm going to cruise down here and pick up my LEDs, and I'm going to go to Osram as the manufacturer, and I'm going to go to the Substitute Advanced 3000 Kelvin 18.4 watts. So this will be this fixture here. And it knows there's 2 lamps per fixture, and there's 114 lumens per watt, right? 3000 Kelvin, 2100 lumens. So I'm going to go ahead and accept that fixture. So Rescreen has helped me to figure out all the parameters of this fixture. I just got an idea of what I want to do, but it's got the internal servers on this thing. Now, my base and my proposed case were identical to begin with. I've now modified the fixture, right? And for the same number of fixtures in the space, Rescreen is warning me down here that I'm going to reduce the light level. So what's a person to do? Well, one of the things I'm going to do is I'm going to go back and check this efficacy, or the lumens per watt, because I have a funny feeling that maybe it's not quite as low as it is specified. So I'm going to go over to this is in addition to what Rescreen. Now, I'm not saying Rescreen is behind. This LED stuff is changing so quickly that there's really no way for a database to keep up. So one of the things I always suggest is we go back and we just take a look at the lumens per watt. In fact, in this case, the fixture I would be using here, the lamp I would be using, 20 watts for 2800 lumens. Well, you know what? That's about 140 lumens per watt. So I'm going to go ahead and dial in 140 lumens per watt, right? And now we see we're marginally less at 3.1%. So at this point, I'm comfortable, right? I mean, we're probably within the margin of error here, so I'm comfortable that I've done this properly. The other thing I'm going to do here is consider adding some switching in here, some control when I actually do the project. So rather than running 12 hours a day in this office for this gymnasium area where it may not be used all the time, I'm going to use some motion sensors. I'm going to drop that to 9 hours a day, right? And the cost of doing this, I'm going to specify to be, including the control and everything, probably around $1,200 on this one. And I can go to my include screen, right? And I'm going to go to my active area lighting. I'm going to click check on that one, and now I get a project evaluation, project with about a 3.8 simple payback. And I can say, well, what would it be if I just substituted those two? Those are pretty much what they are. So I'm going to go back, assume that we don't change the hour, right? And I'm going to change the lighting cost to $400. That's about $20 a tube for, would be about, $10 a tube, $15 a tube for 20 times 2 is 40. So that'd be about $600. And I cruise back to my include measure. And if I don't put that switching in there, it's a good thing. In this case, it's probably not going to give me a good marginal payback. So we're looking at about a 2.5-year payback. Now, it's up to you, but again, you can see how you can run the what-if analysis on these given situations. And maybe I realize that if we're aggressive with the switching, so maybe really the space is only occupied half the time, and then I would be able to reduce the hours. But if we only have a small amount of hours reduction, it might be hard to pay marginally for that particular type of control. So there's 2 or 3 projects. We've done a roof insulation, we've done a building envelope or window upgrade, and we've done a lighting upgrade. So the next I'm going to do, and I'm going to watch my time here close. At this point, I'm going to show you the result of the demand control ventilation. So I've actually done a little calculation here on demand control ventilation to reduce we'll reduce the temperatures in the building first by 1 degree and with a set point, but then we'll put in place a speed control to change the speed of the fan in the exhaust and supply system. And I'm just looking for my mouse here to make sure I go. So this is somewhere near, right? So these are fictitious locations on these ones. It's not actually the hospital in Guelph that I know of anyway. And here we have an individual measure, which is going to be ventilation. And I'm going to do the ventilation. And I've done something similar to what I did before when I looked at the roof insulation. So here I see I've got the furnace and the air conditioning, so I have to heat and cool. And then I'm going to have the specification of the ventilation. So in this case, I'm going to specify in my base case that I'm moving 1,000 CFM of air 24/7. But in my proposed case, I'm going to specify what I really need. And that is I need 10,000 CFM of air for 6 hours a day, and 7,500 CFM for 12 hours a day, and 2,500 CFM for 6 hours a day. Now, I've built schedules to do this. So before I use that 24/7 schedule, so I have schedules which allow me to adjust the temperatures and the times, and I have multiple schedules to use to build up this scenario of using speed control. And you could do the same thing with a multi-speed fan, I suppose, but most people today would do that with a variable speed drive. So I've now got my heat and cooling load restriction specified here. And now I can go to the VFT calculator in Regression, and I can specify that basically I have 5 horsepower fans there, and it was constant speed in the base case. It's variable speed in the proposed case, and what I call high flow, which means that it's not heavily throttled, it's lightly throttled, but still there's some opportunity here if we apply a variable speed drive to that situation, a 44.1% reduction. So we take a look at this measure, and you realize we've got a $1 cost to implement it. We could put the cost between the drive, or the fan, and the ventilation, but one way or the other, the 8,000 is the bottom line to do this, 1-year payback. And as many of you know, when you look at these types of projects, they do have a very, very attractive return. So hence the 1-year simple payback. That's the 4th project, which was basically demand control ventilation. And the 5th project that I'm going to give you a very quick glimpse of here today is a situation where a hospital had retrofitted a boiler with a stack economizer, and they wanted to verify the savings from it. So in this case, we've used the performance analysis part of it. There we go. And I'm just going to make sure Rescreen is going to work with me here today, because I just, hang on, where do we go? There we go. That's the one I wanted. Okay. We've got about 6 windows open right now, and Rescreen is performing admirably. That's pretty amazing, actually. So here we have a hospital, and here we have the data for this hospital. So we have temperature data, which we use to derive degree days. We could a download from NASA too. We could create another table here for the location we're at, and we could download from the NASA satellite database. We really don't have time to do that today, but suffice it to say, it's very easy to access type of data in this situation. So in this hospital, we put a little diary of what happened. So in 2000, at the end of the year, we commissioned an economizer. We actually put the economizer into service for service mode about a year later, and then we discovered an error, and we fixed that error a couple of months after that. So this is what I call event log. A lot of times when we track the energy, but we don't track the events. Rescreen does a great job in this performance analysis tool of being able to bring the facts or the events together with the numbers, and you'll see once we look at some of these analytics what that really does for us. So at this point, I'm going to show you very quickly what I call an overall regression. So what I'm doing is I'm comparing gas compression to degree days. I find a pretty good fit between the two. I can generate a Q-sum. We don't have time today to go into what a Q-sum is, but the long and the short of it is the Q-sum is the cumulative sum of the difference between what I predict using the equation, the consumption to be, and what it actually is. And what I've done here is I've overlaid my events on this baseline or on this Q-sum, the end-to-end, and you can see what's notable here is whenever that Q-sum changes shape dramatically, that is the first mountain right here, that's when the economizer was commissioned. When it's heading downwards, and then when it starts to head upwards again, that's when service occurred. That's an alert that maybe there's a problem, and there was a problem because they serviced it But when they took it out of service, they closed the valve, stopped the water going through, pulled it out of the stack, cleaned it all, put it back in, and forgot to close the valves. When they did that, then they cost themselves a couple of months of savings, which is probably around, I don't know, I think it's somewhere around 80,000 cubic meters of gas in this particular real example. Not a good thing. But then they finally figured it out a couple of months later, and then savings continued after that. So the traditional way to present this would be to do a regression for 12 months, and to do a Q sum shows the savings, the leveling out, which means the disappearance of savings, and then the resumption of the savings afterwards. For those are M&V aficionados, where you do measurement verification, we can actually generate what we call E-chart, a great way to the savings, right? And so this tells us that in the period following the commissioning of that economizer, it saved us 882,000 cubic meters of gas. That's a pretty big building, but you know, this is a great way to show the savings. And I'll tell you right now, before we did this, and this analysis was done about 3 years after the fact, the hospital had no idea they saved this amount of energy. So that's it. That's a very quick tour of Rescreen. Appreciate your patience listening. I know it's been very quick, but I wanted to show you the breadth of what this tool can do. And there are lots of opportunities to get trained on this, not the least of which are some of the videos and stuff that Kevin is assembling on the YouTube channel, and I'm sure you're going to talk a little bit about that, Kevin, but, you know, avail yourself of that. You know, if you're a technical person, you'll probably find you can use a lot of this stuff yourself with those, but there are some good training opportunities as well. So back to the PowerPoint presentation there.
All right, and I'll take over here. Next slide, Lindsay, please and thanks.
Yep. Oh, perfect. Okay,
so probably ask yourself, why take the Rescreen course? Well, the number one answer, of course, would be because Stephen and Kevin are such great instructors. We do learn software applications easier when others are there to teach and coach us along. And I've taken the course myself, and there's a lot of that goes on. And I'll tell you, it's just a great way to learn. And it doesn't stop there. You also get ongoing support and people to call to help guide you through projects. So if you're working on a project, once you get back home, you've taken the Rescreen course, you're running into some questions, you have a contact, a place to call, and someone to help guide you through your project. We also need to become our own better energy managers and reduce our dependency on outside consultants and thereby reducing some of those initial project costs, especially those of us in small to mid-sized hospitals in remote areas of the country. You know, you don't have to go out there and find the expertise. That expertise is available to you right through Rescreen. So it's right there at your fingertips. It helps us to sell those projects. We talked about that. The reporting that comes out of Rescreen is just amazing. And it just helps to become better energy data managers as well. You know, that big data thing that's out there, it helps us to tie into that. And in the bottom line, too, it also helps us reduce our energy dependency and boost our resiliency, which is something that all hospitals across the country and healthcare facilities are looking at. Next slide. So the Rescreen bottom line, it will make your life easier. I've worked on a number of projects for a number of different hospitals around the country. And now that I've learned Rescreen and I'm starting to use it, it certainly makes those project analysis of potential projects go much quicker, easier, faster. And we're using some very advanced technology. So the answers that you're getting from the system are very dependable. Next slide, Lindsay, please. So, Healthcare Energy Leaders Canada, we'll just end with a little slide about Healthcare Energy Leaders Canada.
Sorry to interrupt, Kevin. Lindsay, can you go back a slide? I think you went 2 slides ahead. There you go. Now we're good. Thank you. Sorry.
Okay. Yeah, so if you're looking for some in-house certified Rescreen knowledge. We do have that. We provide audits. We provide a number of services across the country to healthcare facilities. So don't be afraid to contact us if you're looking for any help in any type of project that relates to energy conservation measures or the environment. And finally, next slide, we're at that stage where we're open to discussion or questions if anybody has any. And we'll give a couple minutes for questions or discussion to happen here.
So there were a couple questions that happened in the chat just while folks were presenting. I know Kevin has addressed a couple of them, but just to verbally summarize for the folks that are still on the call, we did have a question about, so I'll just read it here. Is it possible to easily do a comparison between Energy Star Windows versus non-Energy Star certified Windows, and are all Energy Star appliances in the database? And then Kevin just mentioned that it's easy to compare Energy Star rated versus unrated Windows, and the product database has over 13,000 products. It's updated frequently, but of course, if you can't find the specific product that you want, you can choose to plug in your own data.
As I did in that window example, or the lighting example, I updated a little bit.
And then we did have another question about the Windows payback under 9 years being very good. What is the cost as we have a retrofit product that improves existing Windows? So Kevin did answer that one as well in the chat function. So it's important to note that in Rescreen, you'd want to use incremental costs. So if your Windows are at the end of their life, you have to change them anyways. Being that incremental costs are entered, it's the difference between business as usual Windows, so the base case, and the premium Windows, which would be the proposed case. So that's just a quick summary of the questions that came up throughout the presentation, but everybody is free to ask any additional questions to any of the presenters.
So, Stephen or Kevin, is it possible in the finance module here to include any incentives you might get, whether it be from, a Natural Resources Canada program or IESO Save on Energy or any other provincial program?
Absolutely, Kent. There in the finance screen, I have to go back to it, but in the finance screen, there is a place for incentives, so you can dial that in, and it does then marginally or incrementally change the financial results. So yeah, that's a great thing to do. Any of those things. I didn't do that today, but you can definitely do that. And it's a good way, I think, to demonstrate that in some cases the hurdle rate is exceeded by the incentive, which is really what the incentive is designed to do, is to get you to a project that will fly when otherwise it wouldn't.
Can you do that based on just a specific dollar value, or dollar, or cent
typically
value based on kilowatts reduced or anything?
Yeah, some people would, like, depending on if under Save on Energy, you'd say 10 cents or 5 cents a kilowatt hour. But sometimes somebody would simply make a call and get an estimate of what that incentive would be. So there's a number of ways to do it like that. It all depends on the incentive program that's available. And I'm just talking about Ontario now, and right across the country, they have different ways of doing it. So I would look to your program people and then dial that information in. Pretty easy to do.
And this is Kevin speaking here. This is we also have there's quite a few incentive programs themselves and policy departments that use Rescreen to do exactly that, to calculate, well, what will the cent per kilowatt hour incentive need to be, or what type of incentive do we need to provide in order to make such and such types of projects fly. So that's been happening for years, and still happening. So yeah, it's used also to flip that question around and to say exactly like Stephen said, like what would a policy need to give in order to make, say, insulation project works or whatever.
Okay. And
even from the costing standpoint, you could calculate the savings. You could put your target payback or IRR, NPV in there, and then it would tell you what you would have to build the project for in order to have it fly. Sorry, Kent, I interrupted you there, though.
No, it's okay. You had a spot in there where you said I can make some notes.
Yeah.
Is there also the facility where you could upload something? For example, let's say you're doing your project and you had 2 quotes, and for historical reasons, you'd like to keep track of those quotes, maybe the invoice, that
Yeah,
sort
you
of
could.
thing. So everything's in one spot.
Yeah, the way I would do that is, like, there's a way to put a picture in there. And so I
Okay.
would basically make sure that those quotes were a picture file, unless Kevin's got a better way to do it, and then you could upload that. Now, if you had that quotes as text, you could put them in the text box, but there's lots of places to put pictures on almost every measure. So that would be, Kevin, do you have any other suggestions on that one?
Yeah, the other way to do it is to take a portfolio approach. So if you can take the approach of saying, well, I'm going to look at multiple different options, and each of those are going to be an individual RET-screen analysis, an individual RET-screen file. And then when you're in the portfolio analysis, which we didn't get a chance to see today, but in the portfolio analysis, you can actually attach documents right to that. Also, when you're in the data sheet of RET-screen for each of the data entries, you can attach a PDF file or a Word file or an image file, link to it right there. So you can link to external documents right within the data page in RET-screen.
Okay, great, thank you. And
Any
often
more
when we've been doing workshops together, you'll ask the question, what's it costing you not to do this? Is there a do this now stupid kind of button in here that will give you an idea of, hey, we're not doing this and this is what it's costing us?
Well, I think that's what your cash flow graph's about. I remember one gentleman came to a workshop, and his manager, this wasn't in a healthcare environment, but his manager wouldn't do a lighting retrofit in their warehouse and had a 6-month payback. And I had him generate the cash flow graph and the financial page and put it in front of the manager. And I was hoping the manager would look at the net present value or the IRR or something like that. The manager looked at the cash flow graph and said, what are you talking about? $150,000 worth of cash flow over 5 or 6 years. And the guy goes, well, that's what this thing would deliver as real cash to the business, right? And the manager looked at the maintenance manager who was proposing the project and said, why haven't we done this thing yet? So that's to me, that's the cash flow graph on the financial analysis page has that virtue. Kevin, do you have any other suggestions there?
Yeah, no, that's you're exactly right. It's stunning sometimes. I have a friend who worked in the steel industry, and they would not do any project where the payback was not within the current fiscal year. So it had to, realistically have a 6-month payback or not. So that cash flow graph, especially when the numbers are significant, really kind of made people squirm in their seats when they realized what they weren't doing. So that's the way to do it.
Okay, is there any other questions out there from anyone?
Okay, great. Yeah. So what we will be doing is emailing the slides as well as the recording of this webinar. And in that email, we will also send out the email that Kevin provided for future questions about RET-screen, that you folks can reach out to that email address with any other questions that come up. And again, just a big thank you for everybody who joined us today. And have a wonderful rest of your afternoon.
Thank you also to Kevin and the RET-screen folks
presenting
for supporting us here.
Also to Kent and for organizing.
Thanks, everyone.
Thanks a lot, guys.
Thanks, everybody. Have a great day.